This conference will now be recorded.
Okay, fine. Yeah, hi Mohit and Satish, Gino, Kartikeya, Kirti.
And
Kaveri, are you sending the links to the Mamata also?
Yeah, sir.
But why she is not coming?
so why she is
She's
not
all.
coming? Yes, she's all.
Maybe I
Call her, okay? Or else message. Just inform her to reach out to
From
me.
her to reach out to me.
Okay, sir.
Okay, cool. Yeah, fine. Okay, go ahead. So let me open my Paint Microsoft whiteboard. Okay. So what's today's class, guys? What I discussed till now?
Normal distribution is done.
Okay. So let me go with. I can tell you what are the things I did done as of now. So it might help you what not I discussed. Okay. So the first day I explain what is statistics, right? Then what are the type of stats? Okay. Then I explain what is data and its types. Okay. And we seen some technical names, technical terminologies. Now stats like sample population data, okay, statistic parameter, that kind of information. I just explained it. Okay. Next one is I just explained the measure of central tendency, okay, and the measure of what is measure of deviation, right? Dispersion, right? Okay, measure of dispersion. That's what I explained in the second and third classes. And then after what I discussed, guys, tell me. Hmm?
The harmonic mean and stringed mean.
Yeah, that's what measure of central tendency, measure of dispersion, and percentiles and quartiles. Okay, and five summary data. This is what I explained in last classes, right? Then after little bit of distributions also we started, like normal distribution and standard normal distribution and jet score we can apply to convert from the normal distribution to the standard normal distribution. Is it clear or not? Is there any questions are there till now what I explained? So guys, as of now I explain you, I teach you what is statistics, what are the type of statistics are there. So statistics is nothing but it's a field of study, right? To analyze or collection, organizing the data. Okay, and we can do some kind of conclusions on the data with the help of the statistics. After that one, we explain that what are the type of statistics we have it. So there are the two types of statistics are there, and some descriptive statistics and inferential statistics. Descriptive statistics in the sense we can able to summarize your data with the help of some kind of statistical techniques. Inferential statistics is nothing but we can able to do the some kind of conclusions on the data with the help of the some kind of statistics. Is it clear? By the time we are using the some data is nothing but it's a piece of information and it can be measurable, right? There are something like quartile and qualitative data and quantitative data, and like nominal and ordinal, and continuous and discrete, that kind of data types we have it, right? And what is population, what is sample? Population is nothing but it's entire data that we are calling it's a population. Sample means a piece of or a subset of the population. And the statistic is nothing but when you're applying the statistics in a in a sample, then we are calling it a statistic. When you're applying the statistics on the population, then we are calling it a parameters, right? And a variable is nothing but it's a data which is set of data, we are calling it a variable or random variable. Okay, and then after measure of central tendency is nothing but we can able to give the data, or we can able to give the central point of the data. So with help of the mean, median, mode, and harmonic mean, and trimmed mean, weighted mean, geo mean, so different kind of okay, so meaning techniques or central tendency techniques will help you to find out the central point. Okay, measure of for dispersion is nothing but it's a range or variance, standard deviation. Okay, and the coefficient of variance. Okay, am I completed that specific part or not? And the percentile is nothing but 0 percentile. So whatever the data we have it, that we can able to representing in the percentiles or quartiles in a 5 elements. So for that one we can use the q0, q1, q2, q3, q4, and right. Distribution is in the sense normal distribution, or you can say that it's a Gaussian distribution. When you are able to distribute the data normally with a bell curve, that we are calling it a Gaussian distribution, and which is following the some kind of empirical formula. Okay, so for example 68% of the data which is fall in a one standard deviation, 95% of the data which is fall in a second standard deviation, and within the third standard deviation area 99.7% of the data will be fall. Okay, so whatever the normal distribution which is available, which is very complicated, where the data is available, okay, or which standard deviation which is available, which is little bit of tough to understand, so that we are applying the jet code to convert your normal distribution to the standard normal distribution. Okay, so there in a standard normal distribution, the mean can be the 0 and standard deviation can be the 1. And meanwhile we can able to normalize the data with help of the min max scalar. Okay, so within the min max scalar method, we can able to convert your entire data in between the 0 to 1 only. Okay, even the data will be the huge, so it can be converted in between the 0 to 1 only. Okay, that we are calling it say normalization. So guys, as of now I explained this kind of information. I hope you understood some basic techniques in a stats. Okay, is it clear? Is it clear or not?
Yes, sir.
Okay, if you have any questions, please let me know. Okay, any questions? It can be any question from the stats. If you have any question till now, whatever I explained, you can. See guys, as of now we've seen some basic part of the statistics, but if you want to do, as of now, whatever the techniques we have it, that we can do some kind of summarization of your data. Okay, like we can box plot, with help of the box plot we can able to summarize the data, and with help of some kind of scatter plots we can summarize the data. So as of now, whatever we discuss, that is the basic level of descriptive statistics. But in a statistics we have the inferential statistics, right? So to derive the descriptive statistics, whatever I explained previously, those are it's a basic level of, it can help you somewhat. Okay, but when go for the inferential statistics, probabilities are very, very important. So that if you want to conclude the data, if you want to conclusions of the data, okay, and so by the time we are calling it inferential statistics, by the time of inferential statistics, probabilities are playing the crucial role for it. Okay, so let me go for understanding the what is probability. Tell me guys, what is probability? Probability is nothing but you can able to go for measure of likelihood of an event, measure of the likelihood, okay, likelihood, okay, of an event. So for example, when you have some sample space, so sample space is nothing but your data. Okay, yes, you can representing with a yes is nothing but it's a sample space. Sample space in the sense when you are doing some experiment in a multiple times, we are getting some kind of results, right? So each and every result, it can be the some event only. when you're conducting some kind of experiment multiple times, for each and outcome is it's an event only. Okay, or you can say that it's an outcome. Okay, you can say that it's outcome or event. Is it clear or not? So when you are doing some kind of experiment, for each that same experiment you are repeated some multiple times. By the time we are getting some kind of results, the results you can say that the results we are calling its outcome, and the particular event or that particular process we are calling it's a event. Okay, someone is joined with the name of some company name. Who is that? Vaishno Infotech. Okay, so I hope you understood, right? Probability is nothing but we would like to go for measure of the likelihood of event. For example, when you are doing some experiment, we are getting the outcomes are E1, and for example E2 we are getting the event 2, and the same output of the event 1 we are occurred in the third event. Okay, and E4 and E5, for example E3. Okay, and E1 again the same result we are getting. So whatever the result we got in event 1 and event 3, in the same result we are getting in the event 6. This particular situation I would like to go for find out the what will be the likelihood of an event. Okay, by the time we can able to use the probability, I would like to go for find out the probability of the event 1 by this time. So number of events occurred, number of same events occurred by the total number of events. Total number of events. This is the formula for the probability of any event. Okay, so here I would like to go for find out the probability of the event E1, right? So that number of event 1 by the total number of events, that means sample space. Okay, so sample space. So by this time, so the event 1 which is repeated three times, and the total number of events are 6, that means 1 by 2. So here we are getting the 0.5. So the probability of the event 1 is the measure of likelihood of the event 1 is it's a 0.5. Okay, so this is the way we can able to calculate the probability of the any event in a sample space. Is it clear, or any other questions are there? I think this is the probability very easy in your childhood or in your mathematics, in your 9th class and 10th class or intermediate level. We already know this kind of probabilities. Okay, just recollect your information. If you understood this one, then I can go move forward to some examples. Tell me guys, I'm waiting for your confirmation if you're understood or not. Okay, so now my intention is that we will see some examples. Okay, we will see some examples. For example, one is, okay, you are tossing a coin. How many coins you are tossing a coin? So you're tossing only one coin, guys. When you're tossing the coin, so what will be the result? What will be the outcome you may get? It may be head, it may be tail. Yes or no? It may be head or it may be a tail, right? So by this time, I would like to go for find out the probability of the head. So if you want to go for find out the probability of the head, number of times the head is occurred by the total number of results. Okay, so you are getting the 1 by 2. In the meanwhile, probability of the tail, it could be, okay, so 1 by 2 only. Okay, is it clear?
Yes, sir.
Yeah. So let me go with one more example. I think these are the basic examples, guys. Don't repeating the same example in different textbooks. Okay, so you are rolling a die. When you're rolling the die, you might be getting the probability. You might be getting the chances of okay, results are, it can be the 1, it can be the 2, it can be the 3, it can be the 4, it can be the 5, it can be the 6, right? By this time I would like to go for find out the probability of the 3. So the probability of the 3 is repeated only one time. Okay, total number of events are how many? It's a 6, right? So this is the 1 by 6 is the probability of the 3. So this is the way we can able to find out the probability of the each and every event. Okay, yep. So let me go with some complex examples also. These are the basic examples. Let me go with some kind of complex examples. Let me take it. You are thrown the die. Sorry, you are throwing the die 2 times, or so you are dying the 2 dice at a time. Okay, you have the 2 dice. The 2 dice you are throwing at a time. By the time you would like to go for find out the result is the sum of result is sum of the result of the die is, it could be 12, not 12, it could be 10. Okay, so what is the chances of getting the 10 when you thrown the 2 dice, the result of that 2 dice? So you have to do it sum, right? So here when you are throwing the die 2 dice at a time, you might be a chances are you might be getting the 1 comma 1 or 1 comma 2, so 1 comma 3. So one die can be the 1, or second die can be the 1 2 6, right? Yeah, 1 2 4, 1 2 5. Okay, and last but not least, it's a 1 2 6. One die will be the 1, second die will be, it may be 1 2 6. Maybe the second die it could be the 1, sorry, first die it could be the 1, second die it can be changes, right? 2 comma 1, 2 comma 2, 2 comma 3, and so on, 2 comma 6. In the meanwhile, the first die it could be the 1, and there may be chances are, 3 comma 6. Next one is what? 4 comma 1, 4 comma 2, 4 comma 3, 4 comma 5, 4 comma 6. Okay, next one is 5 comma 1, 5 comma 5, and so on, and 5 comma 6. Next one is 6 comma 1, right? 6 comma 1, 6 comma 4, and 6 comma 5, and 6 comma 6. So this may be a sample space, guys. This may be a sample space. The reason is that you are thrown the, or we are thrown the, you roll the 2 dice at a time. By the time you may be getting the 2 results, die 1 result, die 2 results. Here I would like to do that sum of those 2 particular dice results, so that I would like to take the sample space. Here the sample space is the total number of sample space is, it could be the 36, right? So this is my n of s. Here my event, what is the probability I need to get it? Sum of those 2 particular dice, it could be the 10. By the time 4 comma 6, this is one event, it may be occur, this may be one event can occur, this may be one event can occur, right? Total number of okay, total number of sum of, okay, total number of sum of 2 dice results is the 10, which is the 3 times. Okay, 3. So that the probability of the 10 is, it's a 3 by 36. 3 by 36 in the sense it's a 1 by 12. Okay, did you got my point? So these are the some kind of probability examples. A lot of examples are there. You can Google it and we can know it what exactly these things. And this is not much complicated information. You can easily understood, guys. And this is a small example. Okay, so here when you're working with the data, okay, when you're working with the data, or when you're working with some kind of experiments, there are 2 kind of results. There is a 2 kind of scenarios out there. Okay, that means The results, it can be mutual exclusive events, mutual exclusive events. Okay, and second one is the non-mutual exclusive events. Non-mutual exclusive. So you should remember this particular two things when you are working with the probabilities. Okay, and mainly in addition rule, mainly in addition rule, when you're following some kind of additional rule. Okay, so you should remember the two things. One is the mutually exclusive and second one is the non-mutually exclusive events. Let me give some examples of the what is the mutual exclusive, what is not, what is mean that non-mutual exclusive. Okay, for example, you are dying the we are rolling the die. Okay, so here you might be getting the results are either 1, either 2, either 3, either 4, or either 6, right? So you can't get both at a time. From this all, you may get only one event you might be getting. You won't get two at a time. Yes or no? Yes or no? For example, when you're tossing the coin, you might be getting either head, either tail, right? Here also you might be getting only one, not two. Only one result, only one outcome you might be getting out of these two. Okay, so when you are doing some kind of experiment, by the time we are getting only one event from that particular set of elements or set of events. Okay, set of possibilities, we'll be getting only one. That kind of scenario, we are calling it, say, mutually exclusive events. Okay, mutually exclusive events. Is there any question regarding about what exactly the mutual exclusive?
No, sir.
Yeah. Okay, so fine. So non-mutual exclusive, non-mutual exclusive. So it's quite opposite for the mutual exclusive. So non-mutual exclusive in the sense you might be getting the multiple events at a time. Multiple events at a time. Okay. So previously we are getting only one event, right? But in this particular non-mutual exclusive, you might be getting the multiple events. So I'm giving the homework for you. So what are the examples? Come up with 3 examples. So that is your assignment. So make it the assignment, guys. Note down it. Can you give some examples for the non-mutual exclusive events? Minimum number of examples are 3. Okay, go ahead. So you have to submit that assignment by tomorrow class. That's your assignment. See, if you are not understood, then that's not a big deal. I can explain you one more time about a non-mutual exclusive. Non-mutual exclusive in the sense, so when you're doing some kind of event or experiment, by the time you're getting the 2 events at a time. Let me consider your deck of cards. Let me consider deck of cards. Okay, so when you have the deck of cards, okay, I would like to pick only one card. Pick one card. Okay, but there might be chances the card, it can be red. Red is an event, right? Okay, when you have some deck of cards, red number of cards are the events only. Yes or no? In the same red, you might be having the diamond. Yes or no? Diamond shape. So the red, it may having the diamond related information. Red, it may having the heart related information, right? Heart related cards, right? So this is the one event and diamond is the one event. Diamond related cards of the from the deck of cards, that will be the one event. So when you are picking the card, by the time, so the event can be the It can be the red or it can be the deck of cards, or else let me consider black, black, black cards and heart cards. Okay, so in the deck of cards you have the black cards are 13. Okay, and heart related cards also you might have it. From the heart there might be a chance black cards are available. Heart can be available in red, heart can be available in black shape, black color, heart can be available in other different colors, right? Okay, so see, when you are trying to picking one particular card, it may be a, it could be a, it may be a black as well as it may be heart. There is a two chances are there. There might be a two events can come at a time. So that we are calling it say non-mutual exclusive events. Is it clear? Is this clear or not?
Yes, sir.
That's right. So the formula for the mutual exclusive and the formula for the non-mutual exclusive, okay, for the addition rule is different. So that's the reason I'm explaining that what is mutual exclusive and what is non-mutual exclusive. So here the addition rule, so it can be so you might when we can apply the when we can apply the addition rule. The addition rule you will apply when you are able to do the probability of the two events. It can be occur any one of it. Okay, so events, when you are getting the multiple events, any so that particular situation you are using the R, either event 1 either event 2. So when you are getting the or operation, okay, by the time we should go with additional rule. That means probability of the A, okay, or probability of the B, which means probability of the A plus probability of the B. Okay, or you can say that it's a union B, I think so, maybe. Okay, is it clear? So this is the addition rule. Usually the or, when you are using the or operator or operation of the two events, either it can be the A, either it can be the B. That situation, so you would like to go for apply the additional rule. Okay, but this is the formula for the mutual exclusive. Mutual exclusive in the sense when you're doing one particular experiment, you will be getting only one event at a time. Okay, coming to the non-mutual exclusive and A or B. Okay, by the time so you have to go with A of B plus A of B minus, you would like to A and B. See, this is the formula for the non-mutual exclusive, which means that this is the event probability 1, this is event probability 2. There might be chances you might be getting the any one of it, right? It may be a chances both may get, right? So that is the A and B. This is the result. This is the probability of getting the both A and B. So that situation you have to subtract from this particular thing, then only we'll be getting the additional rule result, A or B result. Okay, is it clear? Is it clear?
Yes, sir.
So let me see some examples of those particular uh, additional rule for the mutual exclusive and additional rule for the. Okay, so here I have some sample space. I roll the die. Am I getting the result is 1 comma 2 comma 3 comma 4 comma 6. I could get what is the probability of 1 or and 4 or 6, 1 or 4 or 6. By the time, okay, what is the probability of 1? So the formula is probability of 1, probability of 2 plus probability of probability of 4 and probability of 6. What is the probability of 1? It could be the 1 by 6. Probability of 4 is it could be 1 by 6. Probability of 6 is it could be 1 by 6. So 3. So the probability of getting the 1 or 4 or 6 is the 50% chances are there. Okay, is it clear? So this is the mutual exclusive event. So that's the reason I applied that specific formula. Okay, clear? Is it clear?
Yes.
Yeah. Now here you would like to go with the non-mutual exclusive. So I can take the same example. Okay, so you have some kind of deck of cards. So total number of cards, how many guys in a deck of cards? Is it 52, right? Is it 52 or not?
Yes,
Yes, sir.
52.
From that one, hot cards, how many hot shape cards you might have it? Hot cards, hot, 13 cards, right?
Yes.
How many red cards you may have it? I think so, 26. Either you might have only black and red only, right? In a deck of cards,
Yes.
many number of black cards we have it. That means you have the 52 cards are there. From this particular 52 cards, okay, 26 are the red, okay, and 26 are the black. Yes or no? From this particular 26, heart and diamond only, yeah? Heart shape, and I'm not sure this is the shape is diamond shape. In a black also, what are the shape you might have it? Tell me. Do you
Spades.
know? Anyone can see? Is there anyone playing the cards? If you are having the cards knowledge, tell me. You're also art and diamond only, right? Only two type of shapes, right?
No,
I
in
think.
black there
No,
are
there are
clubs and
four.
spades.
Okay, okay. Clubs and
Spades,
what from the red?
heart and diamond. That's correct.
That's correct only, right?
Yeah.
That's nice. You have the good knowledge. Okay. So here 13 hearts and 13 diamonds, and coming from the clubs there are 13, and the spades which are 13, right? Total 56 or not? And from this particular heart again we have the 2 3 4 5 6 till 9. What could be the 10? Is there any 10? Yes, 10 we have it. And then queen, king, and J, K, I'm not sure. J, K,
Yes,
Q,
sir.
Q,
Yes, JKQ.
only 3.
And yeah, and A's.
Yes,
A.
and A.
Yeah.
Yes, this is common for all, right? The same
Yes.
things will repeated over here and here, year and year. That
Yeah.
means how many Qs are there?
4.
4. Year 1 and here 1, year 1 and here 1. Okay, so I can write this information, the entire information I can write it. So sample space is 52. Okay, number of reds are 26, number of blacks are 26. Okay, and the number of hearts are, it's a 13, number of diamonds are 13, number of clubs are, it could be 13, number of spades are 13, and number of twos are 4, and all rest of all number of A are 4, number of K are 4, number of Q are 4, number of J will be 4, right? This is the number of events of each and everything in a deck of cards. Okay, if you're not aware of it, please go through it, guys. If you're not having the knowledge of this particular information, you could not even solve the single problem. Okay, so when you are working with some particular domain, you should have the domain knowledge. So if without knowledge of the pack of cards, you can't apply the probability, right? Okay, So don't play, just go and get some information. Yep. Now I can give some example over here. And what is the probability of getting the king? Okay, what is the probability of getting the king and king versus king or black? Not black. Yes, let me go with black. Okay, king versus king or black. So here the mutual exclusive is probability of the black plus probability of the k minus probability of the both black and probability of both black and king, right? So what is the black probability for my explanation?
26 by 52.
26 by 52.
Yes, so here I have the totally 26 blacks are there. You just see this particular information. Yeah, you have the 26 blacks are there, 26 by 52 plus how many number of kings are there? You have the 4 kings, right? 4 by 52. And so from the blacks, how many kings are there? So here this is the black, right? Inside of the black, here also you have the one king, and here also we have the one more king. So that means 2 by 52. Is it clear? 2 by 52. Both black with king. Black with king, there are 2 cards are there. So here 52 is my LCM. 26 plus 4 minus 2, which is the 22 by 22, 28, 28, right? 28 by 52. So this is the probability of the king or black. Okay, so here this is the mutual exclusive. So here the black is depending on the, sorry, the king is depending on the black or not. Okay, there might be a chance getting the both. There might be a chance to getting the black and king at both.
So once explain the probability of black and king.
Sorry,
Once explain the probability for the black and king.
black and king. Okay, sure, why not? Okay, okay. Yeah, so for understanding this one, okay, you have to understand the first of all playing cards, okay, or pack of cards. Totally there are 52 cards are there. Okay, from this total 52 cards, 26 cards are the black and 26 cards are the red. Okay, now you got it.
Yes, sir.
So from this 26 there are 13 cards are the one shape, another 13 cards are the another shape. Here also 13 cards will be another shape and 13 cards are the another shape. Here the shape is, it could be heart,
Clubs and spades.
it could be, sorry,
In black, clubs and spades.
yeah, okay, okay. So in a 13 cards, okay, the shape is based upon the shape. So here which is segregated based upon the color. The 52 cards are we are segregated based on the color. Here which are separated, which are segregated or divided into 13 and 13 based upon the shape. Okay, here the shape is, the shape of pack of card is, it could be the, okay, C and S. Here coming to this one, it could be the heart and it could be diamond. So this is the 13 cards, or 2 to 9, 2 to 10. Okay, then J, Q, K, A. So these are the 13 cards of the shape of S, same 13 cards can be available in the C also. That means if the key is available 2 times in the shape of black, okay, yes or no? The key is
Yes, sir.
the key is available here as well
Yes.
as here also. That means the key is repeated in the black. The key is repeated available in the black 2 times. So that 2 by 52. So that means the probability of the both black and king. Okay. So the king is available in the black. It's which are the 22. Okay. So that the total number of cards are 52. Now the probability of the king. The probability of king in the sense there is no color dependency. There is no color condition. So there is no color condition, right? So here also available, here also available, here also available, here also available. 4 times the king is available out of the 52 cards. Then I would like to go for the probability of the black. The probability of the black, the total, it's the only color, right? Total 56 black color cards are there. So 56 by 52, 26 by 52. Okay. Now you would like to go for apply the formula for the, you would like to go for pick the card black or king. So the black color or king. Okay, the formula is probability of the black plus probability of the king. There might be chances, any one of it, right? So but both also repeated, so that I need to remove from this one. Okay, so probability of the black is 26 by 52 plus probability of the king is 4 by 52. Probability of the both black and king is 2 by 52. So the result is 28 by 52. Clear?
Okay.
So this will be the
Yes.
mutual, non-mutual exclusive. Non-mutual exclusive in the sense you might be a chances to get these multiple events in the same event, same experiment. The same experiment you might be getting the multiple events. That's what. For the same event you might be getting the multiple events. So here the multiple events are the black is the one event, king is the one event. So both also you might be getting at a time. So that is also one event. Okay. So that's what mutual exclusive and non-mutual exclusive and addition rule. But tomorrow class we'll see the multiplication rule. Okay. And then after we'll see some kind of permutations and combinations. Okay. After that one we'll see some kind of statistical text like a confidential intervals and hypothesis testing, Z test, T test, ANOVA test. Okay. And so different kind of statistical techniques we will see by tomorrow class. Okay guys, bye, take care, see you.
Bye, sir.
Bye.